higher and higher and higher. So let's just recall, what does it mean to solve an equation? Well, if we have an expression, we evaluate or we simplify. If we have an equation, equal sign, we solve. So we solve an equation by finding all the values of the variables that make the equation true, right? So just because we perform some algebra doesn't mean that the answers we get at the end of the problem are necessary solutions to the equation. We have to check them. We substitute them back in because they could be extraneous. So our goal, our strategy for solving these equations is to isolate the variable. So at the end of our problem, we have x, or whatever variable or variables are, equaling those numbers, or that number. So let's say you're given this. We've done the problem just like this. I have a cubic polynomial equation. Now, if you recall, we can identify the degree of this polynomial as what?
3.
Yes. So the degree is 3. So that means I have how many solutions? If the degree is 3, I have how many solutions?
3.
3, yes, indeed. I have 3 solutions. Now, they may be 3 distinct, unique solutions, or as we will see, they could be repeated solutions. So we don't know yet. So how are we going to solve this polynomial function? I'm going to set everything on one side of the equation equal to 0. So that means I have x cubed plus x squared. Now I'm going to move this 4x by subtracting, move the 4 by subtracting, so I have 4x minus 4 equals 0. Now this is a cubic 4-term polynomial. How do I solve it?
I don't know the word, but
There is a math term.
Split
factor.
You factor. You factor. And in this case, we factor by grouping. Oh, and that's such an important math term. Okay, so we're factoring by grouping. Okay, so I take out the greatest common factor, x squared, leaving me x plus 1. And then I take out the greatest common factor here, which would be minus 4. Again, leaving me that common factor of x minus 1. We're going fast because we've seen it. This is x plus 1 times what's remaining, x squared minus 4. Do I stop there? Difference of 2 squares, right? We have a difference of 2 squares, so we keep factoring. We have x plus 1 times, factor this difference of 2 squares as x plus 2, x minus 2, set equal to 0. At this point, the zero product property says I can take each one of these little factors and set each of them equal to 0. So I'm going to get x equal -1, x equal -2, x equal 3. 2. Now, this isn't surprising. Degree 3, we expected 3 solutions. Sophie? Yes. Move yourself up front. Move. Move. Nobody sits here. This is you now. And if you want to come scoot over here, you can scoot here. Okay. Now, at this point, we're okay with this, but at the same time, we have to be careful because one of them could be extraneous or more. So we have to substitute each of these values of x back into the original equation, checking to see if it's a solution, meaning does it make the statement true. So if I were to substitute each of these in there, tell me, are they all solutions? You're substituting. This should not take but a minute. Bless you. Luke, come on, let's do it. Substitute, substitute. This is the easy part. And, yes? Does x equal -1 work?
Yes.
Yes, okay. Now we're checking x equal -2. Let me know when you know.
Cool, you know.
I know. It's good. All right, x equal -2 works, makes a true statement. What about x equal 2?
It's good.
Yes, so I write my solution set is the set -2, -1, 2. Remember, it's a set of numbers. Numerically ascending order, do not repeat values.
Can you move down?
Down?
Yes. Or up, down. Yeah, that.
You're gonna get me with the numerically assigning order.
Yeah, that's a lot to remember. Now, that's great. That's exciting. But what if we now make it a little bit more interesting and we put radical expressions?
Right quick. To solve an equation means to find all of the solutions.
All the values that
all the
make the
values.
equation true.
I missed that.
You are finding solutions, but what are the solutions? The
The
values
values,
that make
yeah.
it true. All right, now if I look at this beautiful radical equation,
Beautiful. How do we do it?
first thing you want to try to do, if at all possible and may not be possible, is isolate the radical expression. You may have stuff attached to it by addition, subtraction, multiplication. We'd have to remove them. In this case, I have my radical expression isolated. So now maybe think about what could I do to this equation so that I get that expression outside of the radical. What might I do?
Conjugates?
No. Oh, we're having issues, Connor. We are squaring both sides,
Oh.
right? Because this is really 1 raised to the 1/2 power, so to make that a power of 1, I have to square both sides. So if I square the left-hand side, ooh, that expression comes out of the radical. Yay, and what's the right-hand side?
X squared.
X squared. Okay, now I can move everything to one side of the equation, set it equal to 0, and simplify. Okay, so I'm going to move these terms to the right. Do I have to move those terms to the right, or could I move the x squared to the left?
You could do it.
Yeah, I don't care. I like to keep my largest degree term positive. So I'm going to move these. But I get the same thing either way at the end of the problem. X squared plus 8x minus 20 equals 0. That is a quadratic trinomial. What do we do with that? And please use math terms.
Split them out.
Factor. What are my two factors? Beautiful. X plus 10, x minus 2. Zero product property says set each of those little factors equal to 0. Solve for x. I get x equal negative 10 and x equal 2. But do I stop there?
No.
No, because maybe they're not both valid. Check in the original problem. Tell me if they're both valid or if one or more of them is extraneous.
Well, 10 does not equal negative 10.
You are correct. So we're set. So you're telling me this is extraneous.
Negative 10 is extraneous.
Okay, so make sure that you can get a false statement if you substitute negative 10. The left-hand side works, but then you set it equal to negative 10, and 10 does not equal negative 10. Does 2 work? 2 does work. So my solution set is merely the number 2. So you do have to check your solutions. Speaking of which, on the next assessment, I don't know what we're going to do because somehow I went from 11 dinkers to like 4.
What?
I don't know, dinky calculator.
Uh-oh, thinkers.
Yeah, I don't know where they went. All right, what did we say would be a good way to start solving a radical equation? Isolate the radical expression. So that means I'm moving this 6 over by adding 6 to both sides. If I add 6 to both sides, I'm going to get 2x plus 15 equals x plus 6. Does it matter whether I write x plus 6 or 6 plus x? What property tells me that is okay?
Commutative property of addition.
Thank you very much. Now, what do I do to both sides of this equation?
Square.
Let's. Beautiful. Radical. Gone. Right-hand side, I am now squaring a binomial, meaning I have to
Foil.
foil. Yes. If I foil the right-hand side, what is my quadratic trinomial?
X squared plus 36x.
12.
Wait,
Is it 12?
12x.
Yes. Yes. I'm solving for x. What do I do?
I'm going to say subtract the left side.
Okay, so let's get it. All our terms on one side of the equation set equal to 0. So I have x squared plus 12x plus 36. I'll go ahead and show one more stack. Minus 2x minus 15 equals 0. I'm combining like terms. So that's going to give me x squared.
Plus 10x plus 24.
Yes. Factor that. What are my factors?
X plus 7, x plus 3.
Yes. Bless you. So I get x equal negative 7 and I get x equal negative 3. Are they both valid solutions?
Let's check.
What? Oh, okay. I would agree with you. That one is extraneous. Does -3 work?
Yes.
Yes. So my solution is just -3. Very good.
Will we ever have problems with both the solutions are extraneous? Therefore, the solution would be no solution?
Yes, and they even get to the point where you can say that there are no real solutions, but there could be complex or imaginary solutions. Yes, yes,
Let's not
yes,
do
and yes.
imaginary yet.
Okay. I love that you asked that, but yes. All right, just when you thought it couldn't get better, look at that. 2 radical expressions. Now, what on earth?
Multiply both sides by, square both sides.
Do you really want to square a binomial that has 2 radicals?
I really don't.
No, you may have to. If I had a radical expression on the right-hand side as well, might as well just do it. But at this point, I would go ahead and isolate at least one of the radical expressions so that when I square both sides, one of them goes away. Which one you move, I don't care. So I have the square root of x plus 1 equals 1 minus the square root of 3x plus 7. Now, I do have a radical expression isolated on the left-hand side, so let's go ahead, square both sides. So that's going to give me x plus 2 equals, oh my, yes, we have to FOIL this. It's not that bad.
It's that bad.
No, it really isn't.
Yeah.
No,
Yeah, it is.
no, it gets worse.
That's
So
not good.
let's FOIL. First terms are going to give me 1. If I do my outer and my inner, and I combine those.
-2 square root 3x plus 7.
Okay. And then, last terms? Louder. Yes, plus 3x plus 7. Now what?
Does it matter here whether you have 1 minus the radical or the radical minus 1? I mean, the negative radical plus 1.
No, it doesn't.
Okay.
But I kind of want
It doesn't. I just put the positive term
Yeah, 'cause
first.
that works.
No, it doesn't.
Yeah, it
Say
doesn't.
commutative
It's-
property of
right.
additions. Or, no.
Okay.
I kind of want to subtract the left side and then add just the radical expression on the right side and then square that.
So are you saying that you want to isolate the radical expression on the right-hand side?
Yeah.
Yeah, that would be a very good idea. So let's move everything else. I'm subtracting 1. I'm subtracting each of these terms. So that means I have x plus 2 minus 1 minus 3x minus 7 equals -2 times, again, we love isolating radical expressions because then we can just, if the root index is 2, square it. Combine like terms on the left-hand side, and what do I get?
-2x -6.
Excellent. What might you do next?
Square the others? I mean, no, divide by.
-1.
Divide by -2. Could you have done 1? Sure. Could you have gone ahead and squared it this time? Sure. Why? Make it easier. So this is going to give me x plus 3 equals the square root of 3x plus 7. Now it's a baby problem. Take a deep breath and just run with it. What do I do to both sides?
Square.
Square it. Okay, we're FOILing on the left-hand side, and what will I get?
X squared plus 6x plus 9.
Excellent. Equals just 3x.
3x.
Now what?
Subtract 3x plus 7 from, yeah, you know what it is.
Set it equal to 0, right?
That's,
So I
yeah.
have x squared plus 6x minus 3x plus 9 minus 7 equals 0. So that's x squared plus
3x equals 0.
Well,
Right? Wait, did I miss something?
You're missing a term.
I'm very 2.
Plus 2
Yep.
equals 0. Factor that left-hand side. What are my 2 factors?
X equals -2.
Cameron, be careful how you answer that question. I want the entire factor.
Oh, x plus 2.
Carl, that's correct. Yes, you have the right numbers, but when I say factor, I want a factor. Okay, so that means I'm going to get x equal -2 and x equal -1. We do not stop there. We determine if either of those is extraneous. You tell me.
-2 is not extraneous.
Okay, so -2 works. Negative. Oh, y'all are so good. So my solution set is just -2. Machines that you are.
Come on, since you told us to be yesterday. So.
I'm telling you, here we go.
Exactly what you want.
I love it. Hey, look at this. Radical instead of a radical.
Ah!
Have no fear.
Wait, what? What?
This looks a little daunting.
It is.
So maybe I want to isolate that and I want to move everything else to the other side.
Yeah.
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 Square root of 1 plus 4 times the square root of x equals 1 plus the square root of x. That looks a little bit more manageable.
Yay. Now let's square it.
Let's square both sides.
3 times.
So that's going to give me 1 plus 4 times the square root of x equals, yes, I have to FOIL that. It is a binomial. So left-hand side, 1 plus 4 times the square root of x. FOIL the right-hand side, combine like terms, and tell me what you get.
1 plus 2 squared x.
Plus x.
Excellent. No pun intended.
Can you subtract 2 square root x from 4 square root x?
I don't know, can you?
I don't know, can you?
Yes.
Those are like terms, right?
Yeah, you
like
can.
root indices, like radical expressions. Absolutely.
I bet.
So I'm going to move this over by subtracting and this. I'm leaving the x on the right-hand side.
Yeah.
So I have 1 minus 1 plus 4 square root of x minus 2 times the square root of x equals x. Combine like terms on the left-hand side, and what do I have?
2
Times
square
the
root
square root.
x.
Yes, boy. 2 times the square root of x equals x. Now what? Square both sides again. If I square the left-hand side, what do I get?
4x
Equals x squared. This is just a quadratic equation. Set it equal to 0. Factor. 0 product property to solve for the values of x. So you should be able to get x equals 0 and x equal 4. Are they both valid?
0 is.
Wait. Have
And 4 is not.
Really?
Ah. Yeah.
4 doesn't work?
Wait, no. I could be wrong. I kind of just glanced at it.
Don't glance. Do the math.
It works.
It works!
They work.
Solution set is 0 and 4. So these are not bad. They just, you know,
They're
take,
long.
they take. Oh, this is not
Tedious.
long. This is nothing.
Okay, this is better than matrices.
I don't know, matrices are kind of fun.
Shall we go over this?
Like, I know you love matrices.
I love it all.
Okay. I know you have a special fondness in your heart for matrices.
I do.
However,
Because matrices are cool.
they are belligerent
you.
and
They are
numerous.
cool. I like matrices.
They are.
Yeah.
All right, let's go ahead and make sure that if you are given a table of values on a pop quiz or a test, that you can determine whether it is linear, whether it is quadratic, or neither.
Did you just drop a pop quiz here?
I don't know, I'm thinking your test is a little long, maybe you need to have a pop quiz.
Huh. On day 3 back.
All right, so the ones in orange are linear. The ones in pink are neither. The ones in blue are quadratic. So make sure that you got these rules. If not, let's talk.
Let's talk.
Can you pull it down just a bit so you can see the last thing?
Do you like how I email you? Do you like how I email
I know,
you?
I saw
Do you
it, and
like
I
how I
immediately
think of
came
you?
here.
Thank
Do
you.
you like how I think of
I
it?
know. As soon as I got them, I was like, oh, I can do it now. All right, take your pick. You can either have that.
Yeah. What'd you get for number 4?
What's 15?
You got that too? I think we're. Because up there she says that it's not linear.
No, I saw it. I was like, what did you send to? I said this to me and Gloria. I was like, yes.
Not linear or
Nobody else.
Thank you.
Right.
You're welcome.
And if you want, come to innovation space later if there's extras.
Dr. PA, have it.
No, actually, we're in here. So you just come
Right
right
here.
here.
Will you? Because I rehearsed up for it. I'll be. Bye.
Was that the end of the notes, by the way?
Yeah, that was the end of the minute.
Because I was videoing it for
Oh,
for
yeah,
Kate.
no, we're done.
Are we okay? Is
Yes.
there anything we didn't get? Did
Yes.
you fall